should be going at 0.2, 0.002. You're loading an application, you're fading in cache, whatever. So we notice that the first 50 milliseconds, all those spikes that you see at the start, that is the whole nearly first second of the simulation. Most people wouldn't care because most people would say, oh, no, you have to jump, start, and fast forward until first 2 billion instructions and then execute the whole benchmark. But if you're executing a system, that is not only going to happen there, that's going to happen when you wait for network, when you wait for I/O, and when you wait for many things. So if you don't give information back to the system and waiting and not doing anything, and you're not going to have a representative simulation. And you notice that here because here, every time, since everything is running at one IPC, the program IPC, if something goes down, it means that SimNow couldn't find something to work. And that means basically waiting for something. So here you only see that one of the CPUs is waiting, and the other one is basically always on, except for very, very small periods of time in which the yellow one goes a little bit down until the end. So that, although these two applications, one of them, they are like an 8% difference, you notice that it's just sheer luck that they're similar at all. So if you get if you try to get your simulation data out of here, we don't think that that's good enough. That was good enough when you were running only one application in a multi-threaded environment. If you run a multi-threaded environment, you have to take into account that the operating system is going to schedule both threads differently, and that is important. Okay, so after this small thing that we'll get into this, we're going to see, first of all, we're going to see the program, how to program a sampler, and then we're going to see our own sampler so that you can see the dynamic sampler. So let's go to the next one. Okay. Okay, random sampler. As I told you before, most of you will not be interested in sampling per se. So some of you may be interested in implementing your own samplers and do research on how to sample CPU and on simulation strategy, but you have to understand what is the sampler that you're selecting for your particular type of benchmarks. Unless you prefer to run 3 weeks of simulation per benchmark, and if you have lots of machines, you prefer to do the first set of runs as fast as you can and know the accuracy and know everything. So here we're going to build our own sampler so that you get your idea. This is basically a random sampler. It gets 3 metrics, which, here, let's go here. This is the simplest. So it gets 3 variables: warming, simulation, and functional. With the functional, we send it to a particular library, a particular random library, and we decide that we want to have an exponential distribution of this variable. So if you say the functional is 100 million, means that you're simulating an exponential of 100 million in average. So that's the exponential. But the other ones are completely fixed. So we have samplers that play with all of them. And then the most important function here is this one, which is every time that SimNow finishes one sample, one state, it calls you and tells you, hey, I wasn't functional. What should I do now? And this one is very simple. If you're in functional, go to full warming. If you're in full warming, go to simulation. If you're in simulation, go to functional. Notice that the only one that does really something strange is calls this exponential random library that tells you, okay, based on this, how much time? The other two are fixed. So that means that you're going to run, for example, the first time you're going to run warming, then you're going to run simulation, then you're going to run a functional, and that you don't know exactly how much time you're going to run it, and then you're going to run warming, then simulation, etc., etc. We have 2 kinds of warming here. We have detailed warming and we have simple warming. Simple warming, your timer is free to do whatever you want with simple warming, because you saw before that it had functions for each one of them. But simple warming should be, don't do anything with this, just send it to the caches and to the branch prediction. So warm up the caches and branch prediction. Warm up the long hysteresis elements that you may have inside your model. With the detailed warming, basically what you're saying is warm up the short hysteresis system, the elements in your, like the regarded buffer. So basically what we do, most of our models, the simple one, we just send it to the branch prediction and to the cache. And in the detailed warming, we basically think we're simulating and we simulate everything. And then when simulation starts, we clear all the metrics and we assume that's when the simulation starts. So you don't get a cold start of the regarded buffer or the renaming tables or whatever you're interested in. this is more sampling. Okay, so we're gonna run bin run. So the only thing that we're gonna see in this sample is that basically okay, so we got the sim log file, which is the first that we're going to see, which is the output from the sim now that uses. You can see here that instead of having one sample, we got 5, because that's how I programmed the input file, which I didn't show you, but it's very simple. So I guess I changed 1 for 5. So you get those 5 samples. At the end of each one of those samples, our timer, which is, this is a 1 CPU DSD, is going to give us some information. The information there is not really the information that we got out of the timer. That's the information that we decided to send back to SimNow for various reasons. The information that we got out of the timer can be seen in each one of these output, random sampler, A log. For example, the first heartbeat, we call it heartbeat for historical reasons. You get all the information here. You get how many instructions that specific point in time had, how many whatever, blah, 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 blah. Of course, all these samples are exactly the same size, which is because we selected we chose a particular simulation interval to be fixed, that you could change that. And you can see here that another thing is that since we chose to sample randomly, if we run this, again, it should be different. Okay, probably, because many of our tests, we set it always to the same value so that they all reproduce. But notice that the difference between one and the other one is not fixed, so the functional is not fixed. Okay, should we go faster?
Yes.
30 minutes?
Yes.
Okay, so I'm about to finish. Okay.
We have to do 5.
I think you can go over by motion.
Yeah, we should, because they want us to do it. They want to...
Okay, let's go.
So I'll go fast.
I think
okay.
1, 2, 6.
Let's go to dynamic sampling. Yeah. So I talked about before about dynamic sampling. Dynamic sampler is the sampler that we tell everyone to use if you don't want to work in sampling and if you want to work in an environment. And here is the cyan lines, you cannot see them very well. The blue line is the metrics that we're getting from SimNow. I don't know specifically which one is this one, but notice that SimNow is going to change. I don't know if this is how many flashes or how many exceptions or whatever. But SimNow changes, and these changes inside SimNow are very correlated with what's happening inside the application that we simulated. So what we use is we use a model in which we have a median average, a moving average of this variable, and we also have the moving variances of this variable. Whenever you determine that the particular metric has gone out of its moving variance, you determine that a new phase has appeared. And we have a couple of parameters that can be changed there. So let me see input. Dynamic sampler. So here we have a sampler that was hacked up. So these parameters are hacked up for this specific example that we're going to show so that the numbers are pretty. But that is not representative, so we'll definitely. Here what we say is we want how many warming, simulation, and functional we want. And basically this is going to keep on in functional until we determine a change in any of these variables. So if, for example, we chose here that if you see a lot of reads or writes and changes to those variables, you're going to go in. And we also have a particular sensitivity there. And I don't think it's used. Yes, so we are using timer 1, which is one of our most used timers. And we're going to run bin okay, so this is going to take approximately 2 minutes to finish. While it's taking 2 minutes, yeah, we should see the results printed.